Okay, let's tackle this. In this section, we're talking about volume. So volume is something that is three-dimensional, whereas area is two-dimensional. That's why with area, you get things like square inches and stuff, and then with volume, you get things like cubic inches. Okay, so on number 2, we have a cylinder, and it says find the volume. So if we look into the back of the book, we find the volume formula right about here. One version uses radius, the other one uses diameter, so not all that much difference. So that's what we're going to use. And let's see. So they're giving us the radius. So let's use the radius formula, which was going to be, let's see, pi r. Oh boy, I've got doing badly. Pi r squared h, and then that's it. Okay, so pi times the radius of 14 inches squared times the height of 22 inches. And I mean, it's early on in the section, so it's not exactly the hardest problem that we will see. Okay, and it says 1 decimal place, so assuming I've done it correctly, unless I'm wrong, and I'm never wrong, then it's going to be 13,000. What does it say? 546.5, and everything was in inches, so it's cubic inches. Don't forget your cubic inches. And if you just say inches, that's not enough. It's cubic inches. Inches are just a measurement of distance, but cubic inches is how much stuff you can fit inside of a box. Okay, but it says we want to go to cubic yards. Oh, crap. All right, so we got to find a way to get from cubic inches to cubic yards. So we'll go back to our measurements of volume. All right, and let's see, we're in cubic inches, so we can use this to get to cubic feet, and then use that to get to from cubic feet to cubic yards. Okay, so I guess we can just stay right here where we're at and not worry about flipping back to the other one. Okay, so we're going to multiply with cubic inches in the bottom. That way these guys will cancel, and therefore cubic feet on top, and 1 cubic foot is 1728 cubic inches. So yeah, those cancel. Now we can convert from cubic feet to cubic yards. And one of those is 27 of those. The cubic feet will cancel, and we are ready to do our stuff. So we're going to divide by 1728, and we're also going to divide by 27. And at 1 decimal place, that's 0.3 cubic yards. So just under 1/3 of a cubic yard. 1/3 would be 0.3333. So that's how that one is done. All right, on this one, we're going to be laying out, we've got the floor plan of a house, all the shaded region. That's the house. But the dotted lines represent 3 feet away from the house. And you'll notice they're completely surround the house. So we want to lay down a layer of shale so that, it doesn't erode. When we're working around the foundation, it doesn't get eroded. And so we need to figure out how much shale to lay down, because it's going to be all of this, everything that I've shaded in. Okay. All right. So in other words, we are going to go, well, basically the game plan is going to be this. let's figure out, or let's take all of this, break it up as, well, start off with one big rectangle and then we'll break it up. Okay, so that's our one big rectangle. And yeah, I know that we've got extra stuff here that we don't need to lay shale there. I get that. Okay, we're going to subtract that away. Let's see. So it does say footprint dimension. Okay, calculate the number of cubic yards of shale, and it's going to be 20 inches deep. Now, everything in the diagram is in feet. So let's make this 20 inches here feet. So it's just going to be, just divide by 12. And now it's feet. So 20/12 feet deep. Boom. So we got that. All righty. Now, okay, so let's start off by finding the volume of the big thing, the big rectangle. Okay, so the big rectangle is 64 across, and it is, oh wait, no, 64 only goes from there to there. It neglects that 3 feet and that 3 feet, so it's actually 70 feet across. Okay. And then vertically, it's going to be is that a 60? I think. No, that's a 50. That's a 50 plus another 3 and another 3, so it's 56 feet that way. And then 20/12 feet deep. And the formula that I'm using for this is, let's see, where do we get it? Let's go to the three-dimensional ones. Is rectangular prism, because that's really what it is, just one big block of shale that we're doing 20/12 feet deep, 20 inches deep. Okay, so that's the formula that I'm using. That's the only one I'm using in this problem. Okay, so we got that. Now but that includes all of this stuff here that we don't want to include. Well, it's so if we could break that region up into, regions that we recognize, that would be helpful. Okay, so how about we just, there's a couple of ways to do it. It doesn't really matter which one you do. Okay, so let's do this. Okay, so we got all that wonderful stuff. And okay, so we've got this block and this block to subtract away. I guess let's grab that one first. So we know it's 20/12 feet deep. But what are the other dimensions? Okay, so we can see from that guy right there that it's 18 feet from there to there, but we know that's 3 feet of shale and that's 3 feet of shale. So if we subtract those away, then this region right here is just going to be 12. Okay, so we're going to subtract away 12 foot by, okay, now how long is this guy right here? Okay, well, we know that from there to there is 12 feet, but we're not actually including that 3 in getting from there to there, so we're down to 9. But we are going all the way down to here, so that gives us another 3 feet in between that guy and that guy. So it's just this 12 feet right here slid down a little bit. So it's still 12 feet. Okay, and all right, and the depth is 20/12. All right, so that takes care of that guy. Now we have this one to handle. And again, that's where we're not going to lay shale, so we're going to subtract that away. And let's see, how long is it on the bottom? Well, it's 20 and 18 is 38, but the 18 includes that 3 right there that we don't really want. So we're down from 38 to 35. But this 20 only goes to there, and we need to go all the way to here, so that other 3 feet. So we lose that 3 feet, but we gain that 3 feet, so we're still at 38. Okay, so 38 foot across on the bottom, and then vertically, it's going to be just like we did with this 12. Remember how we kind of slid it down 3 feet? Well, we're going to slide this 10 down 3 feet to lose that 3, but pick up that, so it's still 10. Okay, so we've got that, and then the depth is still 20/12 feet. Okay, so now we're ready to plug it in. Okay, so that's going to give us 5660 cubic feet. We're doing volume, so it's cubic. All right, but it does say, hey, give us the answer in cubic yards. So we will divide by the 27, multiply by 1 cubic yard over 27 cubic feet. And that'll give us, let's see, to 1 decimal place, 209.6 cubic yards. That's a lot. You know, those regular old cement trucks you see driving around with the big reservoir in the back spinning. Yeah, that's like 9 cubic yards. So if I recall correctly, so you need about 23 of those trucks, maybe 24. Yeah, it's a lot of shale. Except, you know, it's shale, it's not cement, so it wouldn't be in that kind of vehicle. It'd be in a big dump truck, which holds a lot more. Okay, so but that's how that problem is done. All right, number 16. We're only gonna do part A. Okay. So we got a pipe here, and of course, in the middle of the pipe, it's just air. Okay, so things can actually flow through it, like air, water, whatever. And so there is an inner diameter and the bigger one, the outside diameter. All right, and take a look at how they're defined by the picture. And it says copper pipe is manufactured in 3 types according to wall thickness. Those types are type K, L, and M. And that wall thickness is just going to be the outside diameter. Well, use the outside diameter and the inside diameter measurements from the chart to calculate the weight of the pipe, round to the nearest ounce. Okay, so for part A, we're going size 1/2. All right, so we're looking at that row only. Type L, so that guy right there. And so we want to know the weight. I think that's what it said. Yeah, find the weight. We want to know the weight, and the weight is 5.16 ounces for every cubic inch. Well, cubic inches, cubic means volume. So we have to find the volume of the pipe. Then we can use our magic 5.16 to figure out how many ounces it's going to be. Okay. Okay, so the volume. Well, I think we can agree that this is in the shape of a cylinder with a hole in the middle. And that hole is also a cylinder. So to get the volume, we would have to say, all right, well, volume of a cylinder is pi r squared h, pi radius squared height. Okay, so to get the volume, we have to do the volume for the outside diameter as if there were no hole. Okay. And then subtract from that the volume of a cylinder associated with the inside diameter. In other words, subtract away the volume of the cylindrical hole. So let's do it. Okay, so for the outside diameter, let's see, outside diameter is going to be 5/8, it says. Okay, and let's see, 5/8, if you go 5 divided by 8 on your calculator, that's 0.625. And if we chop that in half, divide that by 2, we get 0.3125. And so there's our radius, just half of the diameter. The height is going to be, well, just how far from here all the way down. In other words, the length of the pipe, 20 feet. But this is in inches and this is in feet. So let's convert the 20 inches into feet, or I'm sorry, the 20 feet into inches, and that'll be 240 inches. Okay, so our height is 240 inches. All right, so that will give us the volume of the pipe if there were no hole, but there is a hole. So we'll subtract away the volume of that cylindrical hole, which is going to be very similar. It'll be pi times the radius of the hole. Well, we know the diameter is 0.545. All right, so if we chop that in half to get the radius, it'll be 0.2725. So radius squared times the height. Again, it's the length of the pipe, so 240 inches. And now we are ready to figure out the total volume of the pipe, which will enable us to get the weight. Okay, so that's going to give us about 17.64 cubic inches. All right. Now, on the calculator, that number goes further. I'm not actually rounding it off. When I do my final calculation with the weight, I will not be using this number. I will be using the entire number on the calculator so as to avoid round off error, so that my answer will be more accurate. Okay, so we've got that. So now we can say, well, we've got this 5.16 ounces per cubic inch. Okay. And if we multiply, well, the cubic inches do go away. We end up with weight. So that's doing exactly what we want. So I multiply it by 5.16. And it says, how do we round this off? Nearest ounce. So to the nearest ounce, it is 91 ounces. It's actually 91.04. So yeah, it's really close to 91. So, but 91 ounces, that would do it. If we divide that by 16, even though they don't ask us to, that's about 5 2/3 pounds. So it's not like you can't carry it around. But that's how it's done. Okay, on this one, we've got a swimming pool we want to fill up. This time, they're not saying find the volume or find the weight. They're saying find the time. Okay, but in order to do that, we need to use the fact that it flows at 14 gallons per minute. Well, gallon is volume, so we need to know the total volume of the pool. Well, you can look in the back, but this shape does not show up. However, in the back, you will notice that if we, let's see if I can draw this thing out very well. If we, let's change colors, then you can see it a little easier. If we take this pool and just for a moment, pretend it's one big rectangular prism, okay, and say, all right, let's find the volume of that, but then get rid of this space here that we don't need. That'll work because we know how to find the volume of rectangular prism. That's no problem. You just say the volume is the 3 dimensions that define it, 12 by 8 by 12, 8, by 20. Okay, so we got that, but what about that shape down here? Well, that's just a triangular prism, and the volume of a triangular prism is going to be the same thing, length times width times height, but cut in half. That's the only difference between the volume of a rectangular prism and the volume of a triangular prism. Okay, so actually, I want this color. Okay, so we're going to subtract from that the volume of this triangular prism, that let me kind of draw that out a little, just in case you're having difficulty seeing it. So it looks like that, and then it goes over there, and it goes up there, and then it goes up there. Okay, so that triangular prism there. And dang, I'm good at drawing. No, oh, I've left, I don't know, whatever. I think you get the idea. Okay, so that's going to be 1/2 the base of 11, whoops, time, and the length of 12, and the height of 5. Okay, so now I'll go to my calculator and figure out what that's going to be. Okay, and so that's going to give me 1590 cubic feet. All right, now, so we know the volume. Unfortunately, this measurement here is in gallons per minute, not cubic feet per minute. So we need to convert 1590 cubic feet into gallons. Of course we do. Isn't that how algebra always is? Okay, so I need to convert go to my volume numbers here. And I can see that, let's see, oh, right here, 1 cubic foot is 7.48 gallons. Cool. All right. So now I am ready to multiply. Let's see, the cubic feet go in the bottom, so they'll cancel. So 1 cubic foot is 7.48 gallons of milk, okay, or gallon containers. All right, so the cubic feet, they cancel. And if we multiply by 7.48, then we get, actually, let me do that over here so I have more room. 11,893.2 gallons. Okay. All right, we're getting close. So we want to find out the time. Now we know that it's, we could multiply by 14 gallons per minute, or per 1 minute, whatever. But that's not going to work, because if I multiply those together, I'm going to get gallons times gallons over minutes. I would get square gallons per minute, which I don't even know what that looks like. So that's not the way to go. So looking at the units is helping me to know what to do. Okay, so what if instead of multiplication, we did division? Oh, well, then that would be 11,893.2 gallons. Oh, that's supposed to be a G. Okay, gallons. And then when you divide by a fraction, you can multiply by its reciprocal. Okay. So I can flip that second fraction over and get this. And now the gallons will cancel and I will be left with time. So this must be the right way to go. Plus the answer is more reasonable. Okay. If you did the first way, you would have ended up with 166,000 minutes. And that's a lot of minutes. Okay. So to the nearest minute, the right answer is 850 minutes. And that seems more reasonable. Okay. So 850 minutes, that's 14 hours. Okay, 14 hours to fill a pool. Yeah, all right, that seems reasonable. But the other one, okay, if we had done it the wrong way, it would have been 166,500 minutes. That would have, whoops, let's see, divided by 60. That would have suggested 2,775 hours. Oh dear. Or in other words, 115 days. That's just about 4 months to fill up this pool. I don't think so. That does not seem reasonable. That does not pass the smell test. All right. Okay, so one more. That's it. All right, so on this one, calculate the weight. Again, we're not finding the volume is not the objective, but we need it to figure out the weight. Okay. So find the weight of the titanium plate in ounces. Now, if this was like plate steel, from the back of the book, we would just need the area of the front. Okay, we wouldn't need the area of anything else. And then that would be enough. But this isn't plate steel from the back. Okay, the plate steel in the back of the book doesn't cover this situation. Okay, that's no problem. But notice titanium weighs 2.59 ounces per cubic inch. So in order to use this number, you have to know the cubic inches. You have to know the volume. So let's go find the volume. Now, to do that, we have to first recognize that, let's go this color. Okay, that we can split this guy up into 3 pieces such that the middle piece, if you ignore the holes, is just a rectangular prism. And the 2 lobes on the end together form a single cylinder. We'll worry about the holes after we figure all that stuff out. All right, so the volume of the whole thing is going to be the rectangular prism in the middle, which is 41 by 32. Okay, because I know that the radius of the outer circle is 16, so that means the radius is 16 there, and the radius is 16 there. And 16 plus 16 is 32. And then the height of the rectangular prism is going to be 4 millimeters. Okay, and that takes care of the rectangular prism. Cool. Now, let's add to that the volume of the cylinder, which is pi r squared h. So it has a radius of 16 and a height, once again, of 4 millimeters. Cool. All right, now we need to subtract away the volume of those holes. We're not doing surface area, so we don't have to worry about every little surface. Yeah, volume's way cooler. Okay, so let's take a look at the smaller holes. They're the same size. So we're going to have 2 of them. And both holes are in the shape of a cylinder. So that's pi radius squared times the height. And that takes care of both of the small holes. So now let's get rid of the big hole, which is also in the shape of a cylinder. And that's pi radius squared times the height. All right. So now we are able to go to the calculator and figure out the total volume. Okay, so that's going to give us 6,580 0.035 or something cubic millimeters. All righty. Now, the titanium is 2.59 ounces per cubic inch. Oh dear. So we got to convert that to cubic inches. All right, cool. So we can convert this to millimeters or this one to inches. I'll just do the first one, the way I was doing it. Okay, so 6580 and then blah blah blah, all that stuff. It's still in my calculators, so I haven't rounded off yet. Cubic millimeters. First, we're going to have to go from the back of the book from cubic millimeters to cubic centimeters. And one of those is 1,000 of these. Okay, so the cubic millimeters are going to cancel. And oh wait, and then I'll just keep multiplying. All right, so then we need to get rid of the cubic centimeters, go to cubic inches. 1 cubic inch is going to be, let's see, 1 cubic inch, where is it? Oh, here. 16.387 cubic centimeters. 16.387. All right. So 16.387, and the cubic centimeters will cancel. And then this guy will be in the units that I'm looking for, which is about 0.4 cubic inches. And again, I've got this to more decimal places on my calculator. I'm not worrying about writing it all the way out right now because I'm not done. Okay, so now we've got 0.4 cubic inches And let's see, if we multiply that by 2.59 ounces per cubic inch, is that going to give me what I want? Yeah, because the cubic inches will cancel. I'll be left with weight, and that's what we want in ounces. Okay, so this one's really anticlimactic, especially for the last problem of the entire course. You multiply that out, and to the nearest ounce, it's 1 ounce. That's it. So anyway, thanks for playing, and don't forget to tip your waiters and waitresses.